Bismillah ar-Rahman ar-Rahim. My dear students at Retail International Academy, I'm going to revise with you what we call refraction, a material we already took it on our school at the beginning of this semester. I hope throughout this revision you will be okay in your exam material for second month and for your final exam. So I hope you will concentrate on it and you will be okay in your exam. I assume most of you know what do we mean by refraction. State what do we mean by refraction. This is a refraction. We call it refraction. We have two different medium. Here at up we have an air media. Here we have a water. So they are two different material. Suppose I'm outside, look at it. What is going to happen? What's happened already here? So I could recognize that there is a bending of pen direction through pencil direction or pen direction on this material. How this come? I could see the bending of light direction when it moves from the two different medium. So light, so I need to see the pen is a reflection light on my eye, so it is a light. How I see it. So there is a bending on its direction. It's not an actual bending, because light have different speed in different medium. Here I have a specific speed. Here I have another speed. So it is give me an illusion. We call it illusion. Light is bending on it. So what I'm asking you, state what I mean by refraction. Refraction is a bending of light direction when it moves from two different medium. How do we judge light direction or light speed in any other material? We judge on it by index of refraction equations. This is what we call index of refraction equations. I know most of you know it already. N, index of refraction, equals C over V. And here, N is an index of refraction. It is a unitless. Doesn't have any unit. You have to know that. C is speed of light at vacuum, and it has a constant value, always at vacuum, 3 times 10 to the 8 meter per second. And V is a speed of light at any other material. So here you could see C is 3 times 10 to the 8 meter per second. And this is going to help us a lot in these equations. Because C is a constant, so I'm able to find any of these. If they give us N, I'm able to find V. If they give us V, I'm able to find N. And by the way, here N is always greater than 1 because C is the greatest, so it would give me a greater value than 1. So N equals C over V. Suppose I have two different material. The first one is index fraction equal 2.2. The second one is 1.7. So I want to compare the speed of light in each one of them. And by the way, without any calculation, you have to know how to judge on speed of light by look at index of refraction. So what is the relationship between index of refraction and the speed of light on any material? You could see that they are inverse proportional, because one of them at top, the other at bottom. We have an equal sign in between both of them, so that means they are inversely proportional. What does that mean, inversely proportional? Because without making any calculation, I could judge on it here. N2 equal 1.7, it's less than 2.2, so it has a greater speed. Less index of refraction, greater speed. Greater index of refraction, less speed. Let us use our calculation to make sure that the equation gives us a right answer. So here directly substituted 2.2 equal 3 times 10 to the 8 meter per second over V. So I'm able to substitute both of them. So V come here, 2.2 come here. Use your calculator. So V for V1 is 1.36 times 10 to the 8 meter per second. So let us try to make this by yourself as I made this one. 1.7 equal 3 times 10 to the 8 meter per second over V. Again, replace each V equal 3 times 10 to the 8 over 1.7 using your calculator. V equal 1.76 times 10 to the 8 meter per second. And you can see less index fraction, it has higher speed. Greater index fraction, it has a lower speed. So they are inversely proportional, and you have to know that by log at the equation without make any calculation on it. If you understand, listen good. State what you mean by critical angle. We took this together. Critical angle is the 90-degree angle between two different medium. It is a 90-degree angle between any two different medium. It will give me 90 degree. After 90 degree, I will have what we call total internal reflection. This is why we call it critical. Critical because it is in between two different phenomena. Less than critical angle, we have refraction. Greater than critical angle, we have total internal reflection. This is why we call it critical. Total internal reflection. How do we calculate it? Total internal reflection. It's easy. Inverse sine n1, n2 over n1. Look at this. I have two different medium. The first one is 1.6, the other is 1.1. How I know this is n1? Because light come from it. So this is the angle. So critical angle, inverse sine 1.1 over 1.6 is 43.4 degree. Less than 43.4, I have refraction. So you could see that I have a refraction. Whenever I reach 43.3, so you could see I have a refraction here. If you could see that now it's 90 degree. And now greater than 43.4, you could see that's total internal reflection. Total internal reflection. What are the conditions? The two conditions for total internal reflection. You have to know it. N1 should be always greater than N2, and incident angle must be greater than critical angle. Suppose I come here to our first look here. I'm gonna switch them 1.1. This is 1.1, and I'm gonna make this one 1.6. Look now. Could we have a critical angle? Either this is the greatest angle I could ever have, no refraction at all, because we have N1 should be always greater than N2. Since we have N1 less than N2, so we are not able to see the critical angle. Calculate the critical angle between N1 equal 1.6 and N2 equal 1.2. If they give it to you in this way, directly just use the greatest one for 1.6, the other for 1.1, and shift sine 1.1 over 1.6 would give us 43.4 degree. So thank you for watching. This is your this is included material for your exams, not all of it. Revise it and revise the rest video I uploaded. You'll be okay in my exam in a few days. I hope you are going to pass on it, and you will have good marks. Happy Ramadan for you all. Thank you for watching, and goodbye.